Okay, hi, good morning. Welcome to the Topos Institute Colloquium. Today we're pleased and honored to have Stephen Clontz from the University of South Alabama. And today he'll be speaking to us about socio-technical infrastructure for mathematics research. So Stephen, whenever you're ready.
Well, thank you so much for the invitation to talk a bit today. I always have to. I've been at South Alabama for like 8 years. I haven't bought new hats since grad school, so I am repping my grad school here on my head, but I am at the University of South Alabama, and I'm on sabbatical, which is always fun. I say always fun. Out of my sample size of one sabbatical, it's been really fun, um, and it's actually been dedicated to this topic is the research and development of this sort of sociotechnical infrastructure, whatever that means for math research. So I'm really grateful to the institution for letting me do something that's not, prove a bunch of theorems, although that's happened too, and I'll talk about that as well. So yeah, there's the abstract. I'm just going to dive on in here. I had written about maybe a good third of my slides, and I was starting to talk about. I was going to like, how do I define glue work? So this is a phrase that my friend James Dabbs, who will come up again in this conversation here in a little bit. I first heard him use this at a workshop we were at 3 months ago. It's a really good word, and I knew it wasn't his like original terminology. He had mentioned this talk by Tanya Riley, and I should have actually looked at it before like a day or two ago when I started to put these slides together, and then I was like looking around for references on what being glue means, and then I found this excellent talk. And honestly, if I was respectful of your time, I would just shut up and play this talk for 30 minutes. But I guess I'll just kind of give you the summary of what this talk is about. Glue work is expected when you're senior and risky when you're not. That's kind of the thesis of this conversation. What is glue work? Um, and this is also a phrase that's kind of particularly used, and I found in software engineering context at least. That's what I've been able to find. That's where I've heard it from, is from software engineers. And so examples in software engineering of glue work would be like decreasing onboarding time. You get new employees, they have to learn the product, they have to be able to contribute to the product. That takes some work to get them acclimated, right? You also have to build things that your customers want, right? And if you're building the wrong thing, you're not going to get sales, you're not going to get revenue for your business. You have to keep your customers happy. You have to make sure that everyone's working under the same, coding standards, and you have to review the design of the product that you're trying to put together. And what happens when you do all that? Well, that's glue work in the context of software engineering. It's not technical contributions, whatever the heck that means. It's not engineering, it's not producing lines of code or delivering specific features of your product. And but it's all stuff that it's really necessary, right? If you wanted to, if in the software engineering context, if you want to make the best impact, like on your customers and on the world, all this stuff has to happen. And who does this work? And so that's where, you know, senior people are expected to do this work. But if you're good at it, you might be really tempted to do it earlier in your career. And that's actually dangerous, because then you get yourself in this situation where you did all this stuff that has to happen for things to operate, but then you don't have your deliverables. You don't have these artifacts of that work. The beans need to be counted. And what are the beans? It's not that stuff. Um, and this is kind of problematic, right? So you can read, like I said, you really should just, after this talk, or if you're on YouTube, just X out the window and go over here and click this. My slides, by the way, are on my website, clontz.org, if you want to get to these right now. Um, but also, it's also problematic because who tends to do that glue work? It's not people who look like me. That's the other kind of issue, is that these things have to happen in general. This is like a research for in general, not just software engineering, not just mathematics. Who steps up to keep things running, and puts aside their individual pursuits, their individual needs for the good of the group? Research says it tends to be folks that are underrepresented, and I wonder why they're underrepresented in these areas. So I'll leave it at that. It's not good, and it's not unique to software engineering. Um, so I want to talk about this for a little bit. We're here because we're mathematics researchers, or at least I'm a mathematics researcher, And in this context here, we have glue work, we have technical contributions. What would we consider in our context in math research a technical contribution? So maybe what you could do is, if you're on YouTube or here in Zoom, either way, you can just post in chat. What would you view as a technical contribution? What's the valuable artifacts of math research, the important things that researchers have to do to get recognized, to be valued in their institutions, organizations. So just go ahead and take a moment, think of whatever, if you think of something, post it in the chat. I'm going to give you a few minutes. I'm going to pull up my chat here.
Yeah, I just want to add that if you're on YouTube live stream, you're also welcome to write your responses in the YouTube live chat, and we will be able to see your responses.
For a brief moment, I thought the only post was going to be writing papers, and I would have been okay with that because it certainly seems that way in a lot of contexts. I know that is the, when I go to get evaluated, we have, and I'm an academic professor, so I have a part of my job is teaching, part of my job is service, part of my job is research. Um, that research or professional development, but professional development or research in my context, it really just boils down to writing papers. Now, of course, to write papers, you have to have new theories, new theorems. You have to prove things, typically in my field, or solve new problems. Um, I think it's interesting, and I think it really is institution or context dependent on whether new effective teaching techniques or writing textbooks would count as a technical contribution. I know I've written a lot of educational material that I don't think has really, and maybe this is on me for not, marketing it, spinning it the right way. It is all free open source educational resources. It's not a peer reviewed published textbook. Um, so sometimes these things are technical contributions if they are posed the in a particular way. Yeah, and someone pointed out in chat, you can have new theories, new problem solutions, but they need to be published and published in the right places. Exactly right. It's not just good enough to prove a thing. It has to be proven, and it has to show up in the right journal, the right article, right? And not all journals are created equally. And again, but of course, also that depends on your institutional context as well, right? In my institution, actually, there's not as much critical. The biggest problem we have at my institution is not whether you're an A level journal or a B level journal. The problem we have at my institution often is, oh, this journal has proceedings in the title. That must be a conference proceedings and therefore not a peer reviewed publication. But we know we have proceedings at the AMS. We just throw proceedings and journal names left and right. It doesn't make a difference generally in mathematics. But when you go to be reviewed by someone who's not a mathematician, oh, hey, speaking of which, what else is a fun thing about the technical contributions in the mathematics? We order our authors alphabetically. And so I actually am first author on the vast majority of my papers. I used to joke with my friend Chris that I wasn't ever going to publish with him. Eventually we did, because his name is Caravana, so he slightly beat me in the alphabet. But my poor friend Scott Varagona down there in the V's has to explain, and that's why the American Mathematical Society put out this, dear colleague letter that says, hey, we order ourselves alphabetically typically. You can just assume they're all equally contributors. Um, oh, yeah. And then it was pointed out that in some fields of engineering, you might be giving a talk at a conference, and that counts as a technical contribution. For us, like me right now talking to y'all, this is not a technical contribution. It's just part of my general expectation of being a researcher and scholar, is to show up places and give talks. But it's not the beans that are really counted. It doesn't count like a paper does. Right. Is there any other things from YouTube that came up? Or have we covered our
Nothing on
bases here?
YouTube right now. Nothing on YouTube.
Yeah. And then something else. Okay, so it suggested new technologies, technical technologies. They share a lot of letters. Okay. Um, so what would be considered glue work then? What are the things that need to happen in mathematics but aren't basically things, everything that needs to happen that's not a technical contribution. What sorts of things, how would our world fall apart if people just suddenly stopped doing these things? How would research grind to a halt? Go ahead, put your thoughts in chat. What are things that need to happen for us to advance mathematics, advance research in mathematics specifically? Um, yeah, reviewing papers. That's the first one that comes to my mind as well. Absolutely. Um, and what's fun for me is seeing that we're much more quick to type these in chat. I think so far, people are like, yeah, here's all the crap I've got to do, and it doesn't count for nothing, but it's got to happen. Um, oh yeah, polymath. Yeah, that's interesting. Yeah, so collaborative mathematics. When you have 100 people tackling the same problem, how does that turn into the artifacts of your labor, of your intellectual labor, that can be counted by the right people? Organizing conferences and seminars, absolutely. I'm very grateful for all the glue work that happened to get me to here on Zoom with y'all today, live stream to YouTube. It is not a just a push of a button. I was here a few minutes early and saw lots of buttons being pushed to make all this happen, right? It takes time and it takes effort and organization to do all this. And now we're getting some things pointing out that, hey, writing software, computer algebra systems, proof libraries, that's kind of glue work. It depends where you're at, but I think in most places and most people I've talked to, they're not getting credit for their pull requests being accepted, merged into the math lib, right? Oh gosh, yeah, making videos, animations. Oh, expository mathematics. Oh, that is a soapbox I can get on any day of the week. Like, it's one thing to prove things; it's another thing to explain it so humans can understand. But which one gets eventually used, right? That's the thing. Yeah, grant applications and management. Again, it really depends. I am fortunate that I have a few sponsored projects that aren't strictly about my math research, but they do count somewhat as a technical contribution. But it really depends where you're at. Some people like money, but some people don't, or some people don't value it the way they should. Oh, mentorship, absolutely. All right. Yeah, any good other thoughts from the YouTube side?
No, YouTube's been kind of quiet today.
That's fine. Okay, that's cool. But yes, this is kind of what I expected, right? There's a few obvious things that count as technical contributions to mathematics. There's a heck of a lot else that we do. All right, there's a lot of stuff we do that is what I would consider glue work. And so again, I want to point out a particular type of glue work. Oh, answering technical questions on Facebook or other forums. Yeah, that's also really good. I spend a lot of my time on Math Stack Exchange, and helping people with their graduate level topology questions, that because that was the best place they could ask them, apparently, compared to their instructor, I guess. Um, yeah, and all these things, a lot of this is what I would consider the infrastructure of mathematics research, or even sociotechnical is the fancy word. I think if you want to get a grant funded by NSF, call it cyberinfrastructure. That's the key word they like over there. Personally, I like sociotechnical infrastructure because it emphasizes there's two aspects of this. It's not just the technologies, although a lot of the things you see on the screen in front of you are involve technology at some aspect, but there's a social aspect to it as well, right? The code could be there, the computers, the servers can be running, but unless there's people using these products and using these products to interact and communicate and work and collaborate with each other, it does no good. So yeah, lots of these were mentioned. Conferences, workshops, seminars, like what we're doing today. Journals, while the paper, right, the published peer-reviewed paper that has a DOI and it's cited on the right databases. Oh, that's the other thing, right? Because especially I hear my friends in Europe have a lot of there's lots of scores that get counted for them that I'm vaguely aware of, these H indexes and whatnot. But if your publication is not cited by the right index, or it's not tracked by the right index of journals, a 3-point paper become a 0.03 point paper, and what's a point mean? I don't know. But I assume it's good and necessary. Um, and then we get into all this informal, I've seen stuff proven left and right on the Math Overflow that is research worthy, and often it does eventually get typed up and put into a paper and goes to the peer review and gets published, and that's good. They finally get their credit. What was the point of all that work that we proved it? It was already proven on the math overflow. We do the rest of it, and I'm somewhat suspicious sometimes that some of these papers get more um, eyeballs on them in some of these journals than they would on this publicly accessible, Creative Commons license. Everything contributed to it is free open source on Math Overflow. The NLab is another big example of places. I've seen lots of work done on Wikipedia to kind of help, lay people be able to dig into some more advanced mathematical topics. There's all this software, you could make pull requests and you can contribute to the Sage Math library, or make a Python library or contribute to R. Does that always count as an intellectual, professional development, what have you? I'm actually in the process of, for one of the things I'm going to show you, writing an article for the Journal of Open Source Software. It's a whole journal that exists for the explicit purpose of, you're doing all this work. It's important. They should have called themselves the Open Source Research Software Journal, because it's about research software in particular. And they realize that if we don't give these people a citable artifact with a digital object identifier and that they could actually put in their CVs, they're going to be getting no credit for any of this work. And then, of course, it's questionable. It depends on who's indexing that journal, how much it counts, and who's counting the beans in your institution, how much that counts. But it's something. So I'm actually writing my first article for that journal for the Pibase project, which is a mathematical database. Bigger examples are like the Online Integer Encyclopedia and the LMFDB for topics in number theory in modular forms. Of course, formalized mathematics these days, especially with these new AI large language models. I think it's going to be really interesting what math papers look like a decade from now, because now we have ways to make some pretty good predictive what would a proof of this look like, and we can check it. If it's actually been formalized, wiring up these AIs together with formalized mathematics, I think it's going to be really going to change in the next few years what mathematics research, like traditional, prove a bunch of theorems in a paper, looks like once that could be automated in some capacity. And then, of course, how do we write this stuff, right? Don, I got to meet Donald Knuth a few months ago. That was pretty cool for me. So he made LaTeX to make his life easier. And then, there's other ways we communicate Markdown and pretext, or other sorts of languages that are used to communicate mathematical knowledge through textbooks and research articles. Or, I wrote this presentation in Markdown. Takes a lot of work and a lot of volunteers. All these are free and open source products. They don't just happen. But did they count for the people who made them? I've done a lot of work on pretext. I have not gotten a single point on my annual faculty report for any pretext work. I can tell you that, but I do it because I think it's important. So the point of this, my thesis is that in math, even the highly technical cyber infrastructure work, legitimate, things that would count as engineering if you were an engineer, it's glue work for us, right? And not all of us have that skill set, and it's mostly folks that are just willing to teach themselves that skill set or happen to come in with it, or just really believe that it needs to happen. They do it, but it's not because it counts. It's not because it counts. And I think that because math is going to change so drastically in the next few years, the way that we prove things, the way that we communicate those proofs, and what gets valued, it's a huge oversight, I think. And we need more people to be thinking about not just how to prove the next theorem, but how should mathematics be done, and how can we help mathematicians do that work, and how can we help make sure that the work that we're doing, whether it's proving a theorem or developing infrastructure to help other mathematicians prove those theorems, that it's valued. All right, and that's kind of been the theme of my sabbatical, such as it is. Where does one begin? One thing I learned about in recent, about a year or two ago, is about the United States Research Software Engineer Association, and so that's a good kind of trailhead, I think, for understanding not just how does research happen, but how does the software that underlies modern research in various fields. How does that happen? And so there's a whole professional organization, which I'm a member. It's free. They have a Slack. It's a good place to hang out and talk shop. If you're interested, you can join them, and I would encourage you to do so. To learn more about what people are doing to write software to support research in other areas. There are some papers computer scientists have written. There's plenty of papers out there on research software engineering. The one I pointed out right here is just this idea of how does one institutionalize, like how does one formally establish a center for supporting research software at one's institution. This is something I have a particular personal interest in. My university is R2, trying to become R1, and I'm starting to float this idea like, hey, there's a fun story that came out of the psychology department in my institution, where I think she was a PhD student. She was working on her dissertation. Her dissertation was studying, mental health issues based on Twitter posts. Now, we might all remember what's happened with Twitter in the past year or two. There was a change of ownership. The API that used to give researchers tools to collect and analyze posts to Twitter that used to be free suddenly cost 5 figures. So what does one do in that situation? When you have your thesis question, you've got your prospectus approved, and now someone's asking you for double your annual salary to do that work. In our case, this person went crying to the School of Computing and knocked on doors, literally, saying, hey, I need some help. I need to do this research project, and my software doesn't work anymore. And my advisor doesn't know how to write software. We don't know what to do. And eventually, one of the faculty members in the School of Computing was kind enough to write a scraper script that just, pulled up twitter.com, x.com, whatever it is now, and just opened the window and scraped it and made a database. And it was very kind of them to do this. That should not have happened, right? There should be a place in modern research. Every institution needs to have some sort of game plan or model for supporting researchers who need software that either doesn't exist and needs to be made, or exists but you have to find it or you have to configure it, right? And it takes a lot of I highlighted this little portion right here, right? Researchers tend to be thrust into this role of developing software. They don't have little or no software development experience or training. They employ ad hoc. It's a nice way of saying they're hackers, right? They hack things out that work. They seem to work, at least. They work good enough. Or they get their students to do it, because if the professor doesn't want to learn how to code, maybe the student, you've used a computer before, young man. You can code this out for me, right? So then that student spends all this time doing that glue work that doesn't count as research when they have to go out into the field and get their jobs. No one's really impressed that they wrote this script that, even though it was the linchpin of this whole research project. So it's wild. This is not a solved problem by any means. There are a few institutions that have these research software engineering, particularly specifically named roles that have these, centers for research software engineering at their institutions that actually hire people to do this work specifically, that are valued for doing this work specifically. So that's in general. Okay. Well, who writes research software in math? Maybe this is another good posted in the Zoom chat thing. Who is writing the software that we use? What is our research software? So you just think about whenever you sit at a computer and you feel like you're doing math. Someone says saints in chat. God bless them. Absolutely. Yeah, no, that might, that's open and shut. Competent mathematicians. I love it. Yes. Good people, good, competent mathematicians that want to support lots of people. William Stein. Yeah, absolutely. Yeah. So William Stein of Sage Math, absolutely. And of course, there's whole communities, of course, around a lot of these products as well. So that's where the saints come marching in, I suppose, as well. Not typically research software engineers, not typically someone with that title, for sure. But my next slide here is really I've got the shrug emoji, because this is all what we think. I did some, yeah, in graduate. Okay, I love this. I did some back when I was a math graduate student, and then I ended up in computer science. Maybe yeah, that's and that was probably a smart play because having looked at my career opportunities, if I had gone the computer science route versus what I'm doing now, especially now that I need computer science to do a lot of what I do. Yeah, it's interesting. The opportunities that are out there and the compensation as well for the computer scientists versus the mathematicians as well. But I put a Strug emoji here because yes, I think this is all right and correct. It's all anecdotal though. I don't believe there's any actual like research. No one's actually seriously sat down and done this investigation. And that's sort of I said my sabbatical proposal was the research and development of math cyber infrastructure. I've definitely done more on the development than the research. I was very fortunate to I taught a course, a special topics course, which is basically random stuff Stephen likes to do, random stuff Stephen learned, like GitHub and Sage Math and math databases that no one taught him, but he finds useful as a mathematician. I taught that 1 hour special topics course, and students enjoyed it. It was mostly computer science students that took it, even though it was a math course. It was listed as. And one of those students is going to do his honors thesis in computer science with me studying mathematical research cyber infrastructure. And so this is where I get to try to pretend I'm something of a computer scientist myself. Or I'm actually going to take a course this summer on research methods in computer science because, golly, it is not just the same as sitting down overleaf and starting to type proofs, right? Don't ask me to define a p-value. It's been a long time since I taught statistics, right? So it's a whole different game. And but I think it's a game that needs to be played. I think it's work that needs to be done. And so working with this student, I'm looking forward to over the course of the next year to do a formal survey to really scope out the ecosystem around research software serving mathematics specifically. There's lots of, like I said, prior art in general, and so I'm hopeful that we're going to be able to just take some of these survey instruments that exist for general research software engineering and just focus in on mathematics, and then we can do some interesting kind of comparisons of what's happening in math versus in general in terms of research software engineering or cyber infrastructure for mathematics research. And I look forward to sharing those results, hopefully in about a year, once we've had a chance to go through and do this survey and analyze it for his thesis. Um, but I've done a little bit of other work, especially the development, especially in trying to get people together. This is where Valeria and I met, was last December at the American Institute of Mathematics workshop on, I think the full title was something like open source cyber infrastructure for mathematics research. Um, I do believe, and that's one thing that I think everyone there, of course, they came to a thing that said it was for open source math research infrastructure, but definitely open source is highly valued in terms of making sure that you're not just building tools, but you're building tools that will be sustained by a community and will be owned by the community and are reproducible. And if you decide to not host that tool tomorrow, someone else could pick up the mantle, right? And we had lots of folks come up and show up for this week-long workshop trying to scope out what the heck this is, right? What is our cyber infrastructure that we operate within? And I was really happy to have a bunch of established mathematicians, a lot of young researchers as well. We had some folks interested in education. I got my buddy James to come pretend he was a mathematician again, coming out of his software engineering hole. I had a few others as well. Emma, I see Emma right there, works for MathWorks. And so we all got together and had to like figure out what is math cyber infrastructure and what should it be and how can we support it. We had a few different working groups, and so we had a really interesting working group. I wish I could have been in all of these, right? But you have to go pick and choose which ones you get to hang out with during the week. So there was a group that looked into basically integration of Sage Math and Lean, so a computer algebra system and the Lean theorem proving language. There's a neat project that came out of this on a database of visualizations. So lots of people create visualizations of mathematical objects or concepts. There's lots of different tools that they use to create these things. There's lots of different ways that they disseminate them. They put them on the internet and get them out there. And so a group put together basically a work in progress database to collect these things. So if you need a picture of X, you can just look for X in the database, and now you have lots of different ways of looking at it. That's not the only kind of mathematical database out there. I mentioned 3 of them earlier. And so it was identified the need for a database of databases. I think that's mathbases.org, if I recall correctly. Oh, good. And so the index of mathematical databases. So if you were interested in knowing how to find a thing, here's 86 of them right here, different databases for graphs, for number theory, for topology, what have you. And so we talked about, both of these things kind of overlap in my mind a bit. Is like, what's the canon of mathematics, and then how these different ideas from mathematics align with each other, and then how will we actually trace when learners go into classes that they've learned things, and what do they need to learn other things, and engage in other things. And there's been a lot of work, like things like Alex, in the education space, but it's all like, these for-profit private companies. They are not sharing their database of learning outcomes of mathematics with the public. Um, we talked about developer on-ramps. Like, okay, great, you want to build the next great widget that'll do this in mathematics research. What do you do to get started? There's lots of information on the internet on how to be a software engineer, but how does one be a mathematics research software engineer? There's no workshops for that. I mean, well, I ran a workshop on GitHub for mathematicians at the joint math meetings to try be one of these on ramps, right? But where do you go and who do you connect with? And also, what are the values of our community? And ultimately, what are we trying to build? Where are we headed towards in the future with all this new novel mathematics cyber infrastructure? Um, and so there's a lot of stuff that I could spend the whole next 2 hours talking about all the cool stuff that happened in that workshop. My recommendation for you is, if any of that tickled your fancy, I would really encourage you to hang out with us at codeformath.org. It's the Consortium of Digital Ecosystems for Mathematics. It's a Zulip chat. Zulip, if you're not familiar with it, is like an open source Discord or Slack. But you are warmly welcomed to join us. All you have to do is just make an account on our Zulip chat, and you have joined the consortium. But it's just a nice little forum for us to talk shop about not just how do we do better mathematics, but how do we actually advance the infrastructure, advance the software and the tools and the services, the web services that we are relying on, or should be relying on, or should have to rely on to make the work of mathematics better, more enjoyable, more equitable, more accessible. Oh yes, and we pitched my talk here. That was the last post that we made. Today, like I said, it's a Zulip chat. Tomorrow, I have a small grant that I'm hoping will give us a booth at the Joint Math Meetings exhibit hall, so we can kind of really like start to market what it is we are. But again, it's one of those things where, we are there's a steering committee of 5 of us. There were about 30 of us at that workshop, and a few other folks have joined the Zulip in the interim. Um, we're working on it. We're going to try to figure out what is the best way, because we all believe intrinsically in this work. We think there are others that would love to do this work if they had the training, they had the support structures. They had a way to know that if this is glue work, if it is glue work for their institutional context, that at least we value them. And of course, we should also find ways to help them have their work valued through things like the Journal of Open Source Software. But how do we turn this glue work into citable artifacts, like artifacts that can go into a faculty activity report? That's the kind of work that we're interested in doing. And anyone who else is interested in that problem space is very welcome to come and hang out with us on the Zulip. Oh, so I guess the last thing I'll do, I got about 15 minutes here, is that, of course, I'm interested in the meta of all this, and I wish I had more like concrete, research to share with you today. It's just getting started on the actual investigation into what is the whole scenery of mathematics cyber infrastructure. Right now, I know what it is just from doing it a bit myself, and I thought I might share a couple of things, the things that are getting me excited, keeping me excited about not just doing math, but building better infrastructure to help mathematicians do their work. Before my tenure, this kind of stuff I considered a hobby. Now I like to, in my heart, I call it scholarship. I call it professional development. They gave me a sabbatical for it, which I guess counts for something here. But again, that's why I'm also writing a paper for the Journal of Open Source Software, so I can have a traditional research artifact that represents the years of work I did on the Pibase. What is the Pibase? I should show you a thing. I think this is this is something that, again, I keep mentioning my buddy James. Let me get that in a new tab so I don't lose my slides. But my buddy James founded it in 2014. We zoom in a bit here for the Zoomers and recordings. I joined it in 2017. Again, it's one of those things where I wasn't going to spend a lot of time on the project. I thought it was cool and necessary, and you'll see why hopefully in a moment when I actually show it to you. But um, it was also a lot of work that didn't count up until I got a small internal grant to do the work. And so it's like the money wasn't even all that important, but the fact that I got a grant to do this project, that's why I decided, okay, James, you can call me the lead mathematical editor. I also contribute these days a lot to the actual software itself that runs it. It's one of these mathematical databases we were talking about. I think it's really cool. We always envisioned this as a very generalized database. It's called topology.pibase.org, not just pibase.org, because I could see a Pibase that serves other categories of mathematics. If you have objects, for us, our objects are the topological spaces, and eventually they'll load. There we go. If you have properties that those objects can have, and if you have theorems that say, hey, if you have, I think I've got too many windows open, so my tabs are going slow. But yeah, if you have a compact space, it's countably compact. If you have a T1 and weakly countably compact space, then it's actually just regular countably compact. If that's described, you could describe your mathematics in that just kind of simple structure, then the Pibase might be a platform that you could use for your research area. Right now, we found it's particularly useful in topology. These are lots of the questions that we ask. Does there exist a continuum, a compact connected in-Hausdorff space that's not metrizable? It's all, we've known for a long time that yes, these can easily exist. And we have 4 different examples in the Pibase, the kind of the canonical examples people would point to, right? But the fact that you can search for this just by knowing the properties. Just try Googling this, right? You're not going to be able to Google compact connected Hausdorff and not metrizable and get a nice concise list of here's the objects. And then when you click the object, here is a reference to the literature where that object can be, that's your trailhead to the literature, right? Yeah, there we go. So counterexamples in topology. In fact, that was the inspiration for the Pibase actually was back in the 70s, there was a research experience for undergraduates, REU program that actually James and my graduate advisor was one of those students before he became a math professor. And they just sat around for a couple of weeks or a couple of years, or a few weeks over 2 summers, and they just crunched out a bunch of glue work, basically. They crunched out all these known results in topology and put it all together into a book with like a database, like literally like tables of ones and zeros. If you wanted to know if there existed a space that had these properties, you had to like get your straight edge and like cover up the right columns, like look for the right crossing of ones and zeros to figure out if that example existed. So this, of course, is now an interactive, searchable version of that tool. We started out with the examples of that were defined in that book, and now we have however many. Again, it's loading so slow, so I have to stall. Right now, we've got about 200 spaces. Got a little less than 200 properties. And then I think about 400 or 500 theorems that wire these things together. The theorems are what's great about this because you don't have to like do what they did to write counterexamples where you had to actually manually check, like, do I put a 1 here, a 1 here? Like we know that every compact Hausdorff space is normal, but if you're writing a book in the 70s, you had to like manually like do that math in your head and like make sure you marked it. There's lots of our errors in that book that we discovered when trying to put into a database that's enforced by the theorems. And now if you want to know something about a space, or if you want to contribute to the Pibase, you don't have to list out all these 400 properties. Which properties does that space have? You could just, for the discrete topology on a 2-point set, all we did was just say it's discrete, it's not indiscrete, and it has not 3 or more points. So it has 2 or less points. And if it had 0 or 1 points, it would be indiscrete. So this is actually uniquely characterizing that. That's all the properties we'll ever need to know about the discrete topology on a 2-point set. And then now, from that information, we know basically every property in the Pibase because it's all wired up through theorems to automatically deduce. Because it's discrete, it's Alexandrov. It's also T1. Alexandrov spaces are P spaces, and P spaces that are also T1 are all omega C. Good question in chat. How many of these database entries are supportive of formally checked proofs? Not, I mean, we have not wired those up. That was one of the kind of what do I want to call it? Like quick hacks that was demonstrated at the workshop that we did back at AIM and back in December. As James actually added a little bit piece of metadata that would let you tag in the math lib where this showed up. So it didn't actually run the check for you. It was still kind of, it was just a reference to where has this been formally verified in math lib. One of the other design decisions that we made with this is that this is all JavaScript. We wanted to, not have to host this on a server, so it could just be run on any static web host. And then it's just, in fact, there's processing that's done, but it's all done through a GitHub action. I'll kind of show you the back end of this. The data is just a bunch of markdown files in a repository on GitHub. So actually, the way that our review process works is actually just through pull requests. People make pull requests to the Pibase editing. If you want to add a new property or edit a property, you just create the right markdown file. And it's just plain text. So you just type it up. And we have some tools in VS Code and code spaces. Again, I just hit period on GitHub these days. I love doing that because it gets me a nice little VS Code in my browser. I don't have to install anything, but it's much nicer for editing and making pushes and such. And then there's a GitHub action that every commit that's made pushes it on, and it takes all this data, crunches it into a JSON blob, sticks it on Amazon Web Services somewhere, and there's just a JavaScript app that reads a JSON blob and does web appy things. Like there's no math. The Pybase knows nothing about mathematics. We do the mathematics in our compile step, and we just have this interface to help you get to it. See, there are other things in chat. I just want to make sure. Yeah. Yeah, so this has been a cool project. Like I said, it's been a hobby for a few years for me. I think that we really need more work to wire this up. And some other things have been discussed is there's a lot of, we're kind of crowdsourcing this information. We call it a community database of topological counterexamples. And the community goes and makes pull requests on GitHub. And speaking of infrastructure, it's really nice because we don't have to maintain GitHub's infrastructure, but it means you have to teach mathematicians how to use, GitHub or Git. It's easier than it used to be. I will pitch really quickly. I have a book, g4m.clontz.org. I really should call it a handbook, called GitHub for Mathematicians. And this is I ran a workshop at JMM. I'm running it again at MathFest in August. It's a nicer way of saying GitHub for Dummies, but it really is focused on specifically for mathematics focused projects. How do you get up and productive with GitHub? And the answer is you actually don't need any Gits. You could just use the tools like this GitHub.dev thing I just pulled up here. And then if you make changes, then it'll just take this file and it'll give you a little, in a moment when it all boots up. Eventually, there we go. It gives me this little thing here. I just push button and pushes things to the right place, and it's great. And it's been really helpful to get folks that are, they're just math instructors that want to write open source textbooks in pretext. I could just put them on a website, tell them go here, click the green button, write your work, and hit the push button, and it does it all automatically for you, which is great. Let's see here. I don't want to go over my time, so I guess the other thing I was gonna show off is kind of some infrastructure work that I've been doing. This one was not expected. I wrote my sabbatical pitch in fall 2022, it would have been, and now it's spring 2024. Because the gears of academia, that's how they roll. Take some time to do anything. So I wrote it during the last academic year. For this academic year, some of the stuff I said I was going to work on, because it's all software and it's changing drastically, from day to day. JavaScript in 2024 is going to be drastically different than JavaScript in 2023. It's true even with mathematics software, how fast things can change. It's something I didn't expect to build, but I did with Scholar Lattice. The idea was that, so this is just a preview at scholarlattice.org. You click through and see what actually, I'll put the direct link in chat here. This is essentially, there used to be a thing called the Topology Atlas. Speaking of infrastructure, a website that people took for granted for 25 years was a Topology Atlas. This was what I would call a science gateway. I don't think the term was coined back in 1990 when the Topology Atlas came out. But it was a place like it had forums, it had a mailing, list, it had a place for announcing conferences. They added abstract submission management. That's the big key one there because there were so many conferences that relied on the Topology Atlas to handle submission of abstracts. It's I need to pull up my I closed it. Let me get this pulled up on my other screen here. I have a pitch deck for the Scholar Lattice that has a kind of a good overview of why this is important infrastructure for mathematics. But yeah, so I built this to run a conference that ran just a few weeks ago, earlier this month. I was a local organizer. Speaking again of how do we give people credit for this stuff? The fact that I made a Scholar Lattice, whatever that was, however many lines of code, who cares? That would count for nothing in a week or two when I do my faculty activity report. But I was a local organizer. I said, I'll do this. Just mark me down, even though I live, 300 miles away. Say I'm a local organizer, and now it counts for something, right? So these little hacks, right, that we have to do sometimes to contextualize the work that we do for people who don't understand it. So I created this website to manage the abstract submission process, the registration process for this meeting. It's not complete. The beta is definitely a beta. I'm going to pause for a second. Things are running slow, and I hope that doesn't mess up my stream here. But yeah, the slide I want to point out in particular is that this is literally what our professional organizations are doing, right? The Mathematical Association of America. This is their cyber infrastructure for running MathFest here in like 4 or 5 months. They've got a website that has some general info on it. They've got Google Forms. Why do we need abstract submission things? We have Google Forms. I mean, so technically you could do that. Yeah, they're doing that to ask for people's suggestions on what sessions should they run. And then when they have the sessions chosen, they made more Google Forms to ask for abstracts for those sessions and ask for the posters to go in the poster sessions. And then they send you off to another website, Cvent, which is a general purpose event management software thing. That's where you can pay, and that's where they upload the schedule. And then, but you get a discount if you're an MAA member. So they got to send you to another website to go to the MAA portal to verify that you are actually a member of the Mathematical Association of America. You should pay $200 less to go to this conference. And this is all I can think of when I see this and I step back. This is us. This is us at the conference every year going, okay, I need to figure out something about this meeting that I'm at or I want to go to. Where do I go? And the answer is you can go to any one of these, and if you look closely enough, they'll put the link to the other thing, and you can just click around, and eventually you'll find where it is you need to go. But it's a pain. And it's especially for the pain on the other side when they have to have all this duct tape. I put duct tape on this slide here. I should have put glue. I should have called this glue because this is glue work, right? We're literally gluing together this cyber infrastructure, these 4 different tools, none of which were meant explicitly for this purpose, but we're trying to wire all this together to try to simulate a cohesive whole for this very necessary function. We identified this earlier as glue work. We have to have conferences. We have to have meetings. We have to be able to disseminate. We can sit in our attics and write papers, but unless we can talk with other mathematicians and share what it is that we're doing, what good does it do? And so meetings are important glue work, and the idea is that, of course, we should have an all-in-one system. It's good because there's smiley faces that appear, right? But really, this could just be a single centralized app. That's what I'm trying to build here with Scholar Lattice. There are things like Easy Chair that are out there that somewhat do this purpose, but they aren't specifically for mathematics. And most people aren't using Easy Chair, which I think is a pretty telling thing. Is that there's a product on the market that people are not using to solve this problem because it doesn't quite solve the problem, at least for us in mathematics. And so that's another project that I'm in an NSF I-Core training program, which is supposed to help turn academic types like myself into entrepreneurs. And so that's one potential sustainability model I'm looking at for the Scholar Lattice. But hopefully this is something one way or the other. I don't care about making $1 million. I mean, I'll take $1 million for it, but I don't care about that so much as I want to help people run their meetings better, because I know these tools are not that hard to build. It just takes some time and some elbow grease to get it out there, and then you have to have people sustain it. But anyways, folks, I think those are the 2 major particular infrastructure things that I've been building recently. I should pull this tab back up. Oh, I did click away from my but here we are. So that's it. Thank you all so much for your hanging out today, and I'd love to hear your questions.
Thank you. Thank you, Stephen. Now we are going to go to the question session for the colloquium, and typically we do it in two different ways. You can raise your hand in the Zoom, and I can call on you to unmute yourself, or you can type your question in the meeting chat if you're not able to unmute yourself, and I can ask the question on your behalf. So yeah, let's see. Are there any questions for Stephen?
Yeah, of course there are questions, lots of questions for Stephen. That's Valeria. I think, Stephen, one of the things that we need to do more, I mean, more like the same workshop that you organized in the AIM Institute, is this business of putting together resources, right? Because as you're saying, we could in the past use EasyChair. We can't anymore because they became they're trying to make money out of it, so that now you cannot use it freely. And there are lots of other people doing things. So my example is that you didn't use the things that we kind of use more, like NLab. It did show up, but not as much as some other things. So there are lots of resources available. It's a question of curation to a large extent, right? And there are lots of kind of economical questions too. The business of, we want free books, free textbooks. We don't want textbooks in mathematics that cost $300 or $200 or something ridiculous like that, right? So
Yeah.
there's lots of work to do. You need another sabbatical.
Yeah, right. I'm having a good time here, and I feel like I'm being productive. I'd love to continue doing this sort of work full time. But no, I've got my courses already assigned for me in the fall, so I know I'm going back to it. But yeah, but here's the thing, right? It's not just the sabbatical, right? It goes back to giving people credit for the work, right? At a certain point, I'm kind of a confident guy. Maybe arrogant is what some people would use to describe me if they're not being so charitable. It's a helpful skill because it lets me stand up and say, no, I'm doing this because I think this is important and I feel like it's being helpful, right? I've been in spaces where I've said the kind of work that I'm doing, and I've been told, it goes all the way back to this slide right here, right? I do all these things, and I get told, yeah, but where was the math? Where was the math and all that? I was like, I mean, I didn't prove a theorem, but I sure as heck helped a lot of people prove some theorems. That's how I feel about teaching some days. That's how I feel about, building these infrastructure, building these software tools that help people do better mathematics and do more mathematics and enjoy doing mathematics. And I believe joy in mathematics is super important because we want more people to do mathematics, and people aren't going to do it if they aren't enjoying it. We drive a lot of people away from mathematics that are great analytical minds because we don't create a good space for them. We don't create, give them a sense of belonging. We don't give them the tools to feel successful. This is all important, and it's not valued. In terms of sustainability, if we could somehow turn this glue into the beans that count, the beans that the bean counters want to see, then we can have a lot more capacity, I think, to have more faculty contributing to that infrastructure. I've basically been told you need to publish 1.5 papers a year, right, to be considered productive as a faculty member. If I was told that I could just swap out and do one paper every other year and just spend more my time, explicitly doing this work, I would. But here's the other side of that as well. What I've discovered is that even though explicitly I was not doing original math research as part of the sabbatical, math questions naturally came up. I've written, I've submitted one paper. I have a draft with a group that's about to be submitted here in another, I think actually this afternoon, we're going to see if it's done and submit it. And then I just started another research collaboration, just a couple days ago. It's all conversations that happened because I did this other work, and we were talking about the other work, and then we're mathematicians. We eventually start talking about mathematics, and then it started some new ideas. And so, so helping people, I don't know if I would have believed that, and I would risk like spending this much time on this work before I got tenure. Because again, it's just like this slide, it's glue work, and it doesn't count, and it's important, but we expect the senior people to do it. I'm rambling though, and someone had their hand up, and I want to make sure I answer their question though.
Sounds good.
Yeah.
Sounds good.
Yeah, thanks a lot, Valeria, and thanks, Stephen. So I think Janet, you have your hand up. You can unmute yourself. Yeah, Janet, you're welcome to unmute yourself if you have a question.
Good. Yeah, wonderful stuff. The most important stuff, this infrastructure glue work, as women in STEM fields, we know very well that, what gets seen and what doesn't get seen. Arguably the grandest of grand challenges relate to this question of improving the infrastructure. And the Topos work in the network mathematics, very important as well. And various other volunteer efforts that have sprung up in the last 30 years is where you see so much value being added compared to where I started years ago, when it's so depressing, and you were told, don't write a textbook. That's that's really bad for your future work. Don't use the word interdisciplinary. That just terrible environment has changed. That's good. Now, I wanted to ask, you said if you call it cyber infrastructure, that will be less, that will actually be more appealing to the powers that be, who would be turned off by glue work, infrastructure, sociotechnical, those other words. Is that the case now?
I mean, certainly there are explicit solicitations from the National Science Foundation that are focused on cyber infrastructure. I prefer sociotechnical infrastructure, but the key word is cyber infrastructure. If I just Google for NSF cyber infrastructure, there's campus cyber infrastructure office. They have a whole office of advanced cyber infrastructure. This is one, that you can just kind of see all these different specific interdisciplinary. You can submit for this particular solicitation if you are in any particular area. You see organizations, all of them, right? So there are opportunities, and I think the National Science Foundation has started to understand, in at least at some point. I actually don't remember how. I want to say, because I wrote this in for my sabbatical proposal, I want to say that cyber infrastructure actually was coined fairly long ago, like in the 1990s, as a need. The federal government had recognized that, if we want to be the leader in science and technology and mathematics, it's not just good enough to have the greatest minds. We have to have the most efficient systems to have them all working together. And so cyber infrastructure was identified as this kind of catch-all phrase. The word cyber in general can be a very modular term. I've discovered. It's a good keyword. It gets people excited, even if they don't necessarily know what they mean when they say it. It's just a good catch-all for fancy techie sorts of things. But cyber infrastructure, like I said, there is some recognition. Yeah.
Yeah. So originally that would have been focused on the technical, the technical side, not the sociocultural side, not the human side. I assume, that when it was, that was my experience of it. And now the impression I'm getting, you're saying that they actually, of course, they talk about cyber physical human or cyber physical social, but now maybe we can use cyber as, well, of course that includes the social and the human. Maybe we can move to that, away from the cyber as just the machine side.
and I want to say yes. Certainly, I hope so. And certainly, it should. And I want to say that I found some particular language to that point in one of these solicitations, one of these sorts of cyber, yeah, yeah. So they are throwing in collaborative in this system. They talk about not just the infrastructure, but the ecosystem surrounding that infrastructure.
Right.
So there are, you know, there was a really like good, and I won't be able to find it probably on the fly here, but there was some really good language that explicitly said that we need not just the technologies, but we have to have this ecosystem of humans that power and use these technologies, and they have to be considered as part of this infrastructure and not just
That's great. Yeah, very encouraging. Very good.
Yep.
Right. Yeah, thank you, Janet, and thank you, Stephen. Do we any more questions in the chat room? So I have a question of my own. So like actually during my PhD and my early work, I did quite a bit of computer algebra software, and so that I can kind of feel the pain of what you're describing here, and as a young researcher, a lot of the work that you do in software or is sometimes not recognized. And the thing is that as you said, you know, a lot of people reap benefits from the work that's done in cyber infrastructure. So for instance, if you're doing research, you often go to at least in category theory, you would often go to NLab and you would look up different things and look at different connections. But when it comes to writing the paper, the site in terms of references of the NLab doesn't often get cited. Maybe you would end up citing the original authors that are talked about in NLab, and so credit doesn't actually go to NLab for being a useful tool they use in research, and because credit is not going to these cyber infrastructural tools, it's very hard for them to justify getting more money or funding, and then also getting departments to recognize the work that was being done. So do you have any thoughts about how to better do credit assignment, how to better give credit to all the great work that's being done, but often in the background, and the work that's really important for helping the community to do research. Yeah, how do you ensure that you get more credit?
So I see Valeria's hand up, and I'm hoping that means she has the answer because I sure don't. Were you going to comment on that, or
Valeria?
No, I was commenting on something else. I was
okay. Well, I'll address that then really quickly then. Which is, of course, I don't have an answer. You know, I'm reminded that I did actually have an answer I posted on Math Overflow once. I had that cited in a peer-reviewed paper. Someone had asked, you know, just a basic trivial general topology question. You know, throw the scare quotes around all that. It was just a particular characterization of the compactness of a linearly ordered topological space or a linear order. It was one of those things where everyone on the post was like, "Well, of course that's true," but none of us could find it in a textbook anywhere. And so, and that's what they were looking for. Is they were looking for a place to cite this folklore result. And I eventually posted and said, well, I thought it was in Willard's topology text, but I looked it up and I didn't find it there. But here's 2 paragraphs that prove it. And so, and they ended up just citing the Math Overflow post, which flew with that, at least that journal and that reviewer. And so I think there are some cases where, and I think it also there, you know, so I think first of all we should just be, as you know, speaking of glue work, when we review things, when we become editors, we need to be mindful that there is scholarly knowledge in places that aren't just the peer-reviewed literature. You know, in some cases like that, where it's a folklore, like they could have just asserted it and nobody would have blinked, right? This was just a nice value add for the reader, if in case they wanted to not have to figure it out for themselves. So I think that that's part of it. It's just, you know, we have to change the system from the inside, right? But then there's also the other issue is that's great. I got cited. I didn't get any credit for that. That doesn't count for me for anything. It doesn't increase my H index. That's not something my institution looks at, thankfully. But if they did, it wouldn't matter. It's just another bit of just, I volunteered to help this person with their paper and even got cited in a peer-reviewed publication, but it didn't count. No clever solutions, just lots of problems. That's why we put together this Code for Math thing, codeformath.org. I really, if you are interested in not just developing, we want to support people that want to just work on better technology for mathematics, absolutely. But I'm really interested in this meta of it all, this problem space of how do we actually help the people that are doing this and make sure that they are valued and make sure that they are given appropriate credit. Because if we want better infrastructure, we need to help the people that are building it, and we need to help that, make sure that counts. And we can get a lot done through our voluntary efforts if that counts as scholarly activity, right? I don't get paid by the word for my research articles. I get paid to be a researcher, and if this work counted as research, it would be very helpful.
Thanks, Stephen. I think that these projects that you started are really helping to change the environment around this, and I think it's a great first step. So Valeria, do you still have a question that you want to ask?
Well, it was more like a comment about kind of, all the people that we know that do this work, like the guys who write LaTeX packages, Knut himself who wrote LaTeX, or Lamport who wrote LaTeX, and Knut who wrote TeX and stuff like that. So I think one of the things that Stephen is talking about is this need for more interdisciplinarity and transdisciplinarity, right? It's kind of computer scientists with mathematicians, with biologists, with epidemiologists, with kind of engineers of all sorts of stripes. And I think it's very important to kind of to bring up the fact that this glue work really needs to happen. It's not, otherwise we can't do anything. And I think that, Stephen probably didn't see that, but it's one of our first blog posts in the Topos Institute was about exactly creating this systems that kind of communicate between mathematicians and others. So nothing.
Thanks.
Nothing new. I haven't got a solution, Stephen, of course not, but we're trying.
Yeah, and that's a really quick comment, Valeria. And I think even in the short 15 years, I've been in math. I'm seeing things change, and we're starting to see more people talk about cyber infrastructure. I mean, like I was very encouraged to see Terence Tao talk about proof assistance, changing the way that we do projects, like say the liquid tensor experiment and things like that. And there's a lot more talk publicly now about the importance of these of cyber infrastructure. So it's very encouraging to me.
Yeah.
Okay. I think now it's a good time to end the live stream on YouTube. So let's thank Stephen again for the wonderful talk. Thank you so much for sharing and for answering our questions.
Thank y'all for having me.
Okay. Just end the live stream now, and we'll go on to the Zoom chat room.